Hi and welcome to Geeks for Geeks. Today we would be discussing the problem polynomial addition. In this problem, we are given two polynomial equations and we need to add those equations and return it. And the polynomial equations are represented by a linked list. So before moving forward to the problem and discussing about it, let us first discuss the polynomial addition and revise our concept about polynomial. Okay, so basically what is polynomials? Polynomials are algebraic equation that contains variables and coefficients, where the coefficient would be this and the variables would be this and the exponent would be this. And this is known as the operator itself. So other example can be 3x minus 4 and this is known as constant. But constant is not given here. Why? Because that is given like this here, x to the power 0. So we don't have any constants here, we have the polynomial. The constants are ignored in this question, but still this is known as the constant. X to the power 0 is equals to 1, where it is given here that x to the power 0, but we have 4, because x to the power 0 is also known as 1 itself. Okay, we are again clear with the polynomials. Now let us move forward and do some polynomial addition. In the first one, we are given as 5x square, and next we are given as 4x1, and then we are given as 2x to the power 0. And we are told that anything to the power 0 is 1, so basically constants are ignored, and this is given. This is where I just told, and this is the example of it. Now, we need to add this equation. So what we do is, we group the like terms together. What do you mean by like terms? Which have the same exponent, okay, same exponent as well as the same variable. Like same variable, same exponent, we would add that. Like 4x square plus 5x square would boil down to the conclusion that 9x square. How do we have this? Let us write this again, 4x square plus 9x square. So we would take x square as common and then 4 plus 9, which would be nothing but x square multiplied with 13, 4 plus 9, 13. This is known as 13x square. Okay, fair enough? This is the same idea. Okay, now we would group this like terms together. What we would do is 5 to the power x to the power 1. So minus 5 x to the power 1, we would write it here. Okay, then minus negative 5 x to the power 0. So negative 5 x to the power 0. Now we would write it down. Okay, so plus minus is equals to 1. So we would simply write minus 3 x to the power 0, and here it would be minus x to the power 1, and this would be 1. Okay, and this would be 5x square. So we can simply write it as minus 0. Okay, this is how the equation would pop in, and this is how we would be getting this output. Okay, let us do one more so that we would be more clear. Here we have 5x3, then we have 4x2, and then we have 2x to the power 0 itself. Fair enough? Then I recommend you that you should stop this video at this moment and you should do this on a pen and paper and then see the result. Okay, then we again have 5x to the power 1. Here we don't have x to the power 1, so we would simply write it here, x to the power 1, and then we have x to the power 0, so minus 5 x to the power 0, and where we don't have anything, we would simply write plus 0 because that won't affect the result. So we have 5 x to the power 1, and then we have 5 x to the power 3, and then we have 4 x to the power 2. Okay, then we have minus 3 x to the power 0, and if you look at the result is the same. Okay, minus 3 x to the power 0, ordering does not matter. In a polynomial, 5x to the power 1, so we have this, then 4x square, then we have 4x square, then 5x3, because even if we write 5 plus 4 and 4 plus 5, these two are absolutely the same. In the same way, even if we write this with a different ordering, that would be the same. Okay, fair enough. So now we need to add this. Okay. So adding this, we saw that we are writing that whenever we are getting in this pen and paper, whenever we are getting a like term, we are adding it there. Whenever we are getting a new term, we are just writing it without anything. We aren't writing anything. So what we can do is, we can simply hash these values. Okay, we can simply hash these values. Like we have never seen x to the power 1, so we would keep x to the power 1. Then x to the power 3 we have not seen before, so we would write it here. X to the power c 2 we have not seen it, then we would write it here. So let us do this. Okay, let us do the dry run and then you would understand it much better. Okay, so what we can do is, suppose x to the power 3, we don't have anything as of now, so we would write x to the power 3. Then we have 4x to the power 2. X to the power 2 we don't have anything written, so we would have 4x to the power 2. We are all segregating based on the powers. We have not seen x to the power 0. Okay, so 2x to the power raised to the power 0. We have this. Then we have 5x to the power 1. We don't have here. We have only 3, 2 and 0. So we would have 5x to the raised to the power 1. Then we have x raised to the power 0. So we already have this. So we would have 5x raised to the power 0. And then we would simply add positive here. Now what we can do is, at the end, we can simply add them and we can write it. 5x to the power 3. Then we can write 4x to the power 2. And then we can write minus 3x0, which is this one. And then 5x to the power 1. And we have this. We can do this. Okay, we can do this. So we now know a way to solve this. But we are told that this is represented using linked list. Let us see the implementation through linked list also, so that we would discuss how we would do it and these all things. Okay, so let us move to the implementation of the linked list, representation by linked list. So we can see that we have 5, 2, and then this would be the next pointer. So this represents 5x raised to the power 2, and it would go here 4x raised to the power 1, which would now have this 2x raised to the power 0. Okay, then we have 5x raised to the power 1. Then we would have 5x raised to the power 0. And then if you add this again, you would find this result, which would be 5x raised to the power 2 added to 9 raised to the power 1 plus 7x raised to the power 0. So we have the node structure as coefficient, power, and the address of the next node itself. Okay, this is how we would do it. So now if we need to save this x raised to the power 2, 3, 1, 0 and 1, we need to hash these values. Now to hash these values, we can either use a map which has a time complexity of insertion and finding that result with an expense of log n, or an unordered map which has an average time complexity of 1, but in the worst case, this is big of n. So can we do better than this or not? Why? Because for each insertion, we would be doing log n operation. So for each insertion and retrieval, for one operation, in the worst scenario, we would be doing n operation. So for n operation, we would be doing n square operation, which is even worse than map in the worst scenario. So we need to find a better alternative to this. So now let us try to solve this. Now to solve this, we can make use of a fact that in this question we are told that the polynomials are sorted in the decreasing order of power. That means that it would be like x to the power 3, then x to the power 1, and then x to the power 0. But like they are sorted, okay, they are in the sorted form. Okay, so what we can do is, if they are in the sorted form, let us take this example. Okay, let us take this example. If this is in the sorted form, we can do the merge operation of merge sort. If you're already familiar with merge sort, then this won't be anything to you. But if you're not familiar, don't worry, you don't need to go back, I will teach you. So what we basically do is, we have a pointer here and a pointer here. We have a pointer at here and here. Now what we would do is, we would see that which one is higher, because we need to return the linked list from higher to lower. So which one is higher? So we would take 5x to the power 2. Okay. So we have taken it. So now we would move the pointer ahead. We would move the pointer to 4x1. At this scenario, there is one little modification from the merge sort, where at this scenario, there is no greater or no less. It's the same thing. If it's the same, what we would do is minus -5 with +4 is equals to -1. So -1x raised to the power 1. And then we would move both the pointer, because these were same. If they are same, we need to add that. So then we would move both the pointer here and in here. Here we again found out that yes, they are also equal. So we would just have -5, +2, that is -3x raised to the power 0. And then we would move forward both of them, where this would be here and this would be here. The iteration has ended and this is done. Okay, this is how we would do it. But there is one more thing to discuss. Okay, that is, suppose we have a value like 9x raised to the power 3. Then we have 9x raised to the power 2. And then we have 9x raised to the power 1. Basically, we have everything as 9 to generalize this. Or let us remove this 9. Or let's keep this 9. Okay. And then we have the next one as 5x raised to the power 3. In this scenario, we would have a pointer here, we would have a pointer here. So both are equal, the powers are equal. So we would simply 9 added to +5 is equals to 14x raised to the power 3. And then we would move ahead. If we move ahead, we are at the null point of the linked list. And we would move ahead both because both were equal. At this point, one is at the null and one is at not null. So if any of these things reaches to null, okay, what we would do is we would simply say yes, the rest of the answer would be contributed by this. Okay, so we would have 9x square plus 9x. Okay, we would have this. So we would simply use a loop which would go when both of them won't be null. And then when we would come down, we would check if any one of them is not at null position, because if someone is not pointing to not a null position, that means that whole of it would contribute. After that would contribute, so we would take that simply. Okay, so suppose we have this like 5x raised to the power 3, then we have 2x raised to the power 1, and then we have just here nothing, then this would be contributed, this would be the answer. The same thing we are doing here also. Fair enough? Now let us move to the implementation and you would get a proper understanding of it. And I would keep telling you as we move forward. So here first what we need to do is we need to return the head, but we are basically moving forward. So to remember it, what we would do is node star res is equals to new node. Okay, we would simply create a new node of 0 and 0. Okay, then what we would do is we would again create a copy and this would move forward or backward. Okay, we would name it as prev and we would name it as, and we would just a copy of it, and this prev would be the thing that would be moving forward, and this res would remain at the head and we would just return res dot next. Why? Because this first point was created by us, which is not a part of the answer. Okay, now I told you that while P1 is not equal to null and P2 is not equal to null. Okay, we would go down, and the first thing we would say that if P1 of pow is less than P2 of the pow thing. Okay, if P1 is less and P2 is more, so we know that we would take the values of P2. Okay, so previous of next equals to P2, and then we would say P2, you please move forward. P2 is equals to P2 dot next. What just happened here was, see, we have here x raised to the power 3 and x raised to the power 1, and here it was x raised to the power 2. So we took up this value, had this as the answer, and then we told now have it here and here. Okay, we just took the large value. Okay, now just the reverse case of it. Okay, when the next one is small and the first one is large, so we would take the value from the first one. Just the vice versa of it. The P1 of pow is greater than P2 of pow, and then previous of next is equals to P1. We would take the values from the P1 because one which is larger, and then we would say that P1, you please move forward. Okay, P1 is equals to P1 of next. Simple. Values, we took values from P2, so we would make the pointer move forward. We are taking values from P1, we would make the pointer of P1 move forward. Okay, and then the else condition where they both are the same one. If they both are the same one, we can do the operation on either on P1 or either on P2 because both are same. So let's do it on P1. The P1 dot coefficient is equals to P1 plus equals to, or which is equals to P1 dot coefficient plus P2 dot coefficient. We would simply add both of them, and then we would say the previous of next is equals to P1 because we had the result in P1, so we are making the P1 as the next value. Okay, we had this, and then we would have both the pointers move forward because both the powers were same. So now we would make both the values move forward. P1 is equals to P1 this next, you move forward, made the pointer of P1 move forward, made the pointer of P2 move forward. We had both the pointers move forward, and after this we would simply move the pointer of the resultant also. Like previous should also move forward, no? Because we would have the values in whatever condition we have. So now previous would be previous is equals to the value of next. Fair enough? Then I told you that whatever is if something is remaining at either of them, we would have that value. If P1 is not equal to null, okay, I would again tell you what this is all about. X3 plus X2 plus X1, and this was like X3 and X3. So these two values would get added, and at this point one is null, this would be false, and this won't be running. And after that we know that if P1 is not equal to null, we would take into consideration all the rest values of P1. So we would simply do that only, like P1 is equals to previous of next is equals to the value of P1. Okay, if P2 is not equal to null, the vice versa of it, then previous of next is equals to P2. Okay, then I told you that this value 0 0 we have given it, we have initialized with my value, but rest all values are the values of the resultant, so we would simply have rest of next. You can do this without, like, you can say that if so you would need other condition, that if the value is null, then you should assign, else you should assign the next value. You can have this, but to simplify the process, we had a value of our own, so that every time we can assign the next value. Okay, Let us submit this and see if we are getting corrected for the sample test case or not. Okay, we are getting corrected for the sample test case. Now let us submit this and see. Yes. Now let us quickly do a dry run. Okay, quickly do a dry run for the very first one. This one. Okay, so initially we have as x raised to the power 2 and this is x raised to the power 3. We have this and both the pointers and we have a res here which is 0 0, which is 0, and then we have the pointer here because both will be pointing to the head. Both is not equal to null. So in this one, p1 power is less than p2. Okay, so we would take the power of p2, that is x raised to the power 3, and we would move this pointer to here, that is the null point. Okay, the next time both should not be null, but one of them is null. So this loop would exit from here and turn to false. Now p1 is not equal to null. Okay, what we would have is we would simply have 1 x raised to the power 2. Now we know that the rest would be pointing to this one. This is our created value. That is why we are returning x to the power 3. That's it for today. Thank you and have a nice day.